All right, hello everyone. My name's Jim. Thanks for coming to my talk on extending drone, a continuous integration journey. And since you're here, I hope you're interested in continuous integration and continuous delivery. Of course, this talk will be about drone, which is a continuous integration solution from Harness. A little bit about me. I don't work for Harness. I am a principal software engineer at Meltwater. I've been with Meltwater now for about 6 years, and you can find me on Twitter, Bitburg. I live in New Hampshire. Meltwater is a software as a service company. We provide services around media intelligence and media monitoring. If you want to learn more, you can check out meltwater.com. I work on a team that is part of Meltwater Engineering's foundation mission. We build and run services and provide solutions for Meltwater's engineering teams. We have around 250 to 300 engineers in 30 to 40 different teams. And Meltwater engineers are our customers. We're building things for them. So Meltwater is a global organization. We have engineering teams all over the world, so it can be a challenge to communicate with all these teams in other time zones and promote the services that my team provides. So it's been vital for us to provide high quality services that teams want to use and spread through word of mouth and throughout our internal engineering community. So one of the services that we've been running is Drone. And why should you listen to me? Talk about Drone. Well, we've been running Drone for about 3 years now. We launched as a service in June of 2018 to our internal engineers. And Meltwater engineering teams, they have a lot of autonomy. So we don't force them to use our solution over a commercial solution like Travis or CI or Circle CI. They're free to use those if they want to. Our job is to provide high quality services that meet 70 to 80% of engineering teams' workloads, and Drone has been very successful for us. It's been adopted by the vast majority of teams, and it's really become a part of the plumbing of daily life within Meltwater. So to give you an idea of usage of Drone at Meltwater, here's a graph of the number of individual pipelines run for the month of April. You can see weekends get pretty quiet, but during the week we can be running anywhere from about 1,000 to around 1,300 pipelines per day. So with this talk, I want to take you on a journey with Drone. And I could go through the past few years of our experience with Drone over that timeline, but if you're picking up Drone in 2021, you'll have a very different experience than we've had. So instead, I want to imagine a team, maybe in a startup, that decides to run Drone as a service for its engineers, and the challenges that they experience and the solutions that they implement to extend Drone to meet the demands of their organization. So to tell this story, I'll be sharing architecture diagrams showing the relationship between Drone components, as well as code samples showing how you would actually run each process. So this talk will be from the perspective of running the Drone service, not from how you would write Drone pipeline YAML files, which would be more from the developer side of it. So this is from the side of actually running the service. If you want to learn more about how to write Drone YAML files, there's lots of great documentation at docs.drone.io. So if you've never tried Drone, Drone provides a free cloud service for public GitHub repositories at cloud.drone.io, where you can get a good feel for Drone's capabilities and decide if it makes sense to try running on your own infrastructure. Drone does offer an open source licensed version, but most of the features I'm going to talk about require the enterprise license, and we've been enterprise customers since the beginning. So here's our imagined team of engineers working together to bring up the Drone service. So first, they launched just the Drone server process. And it looks something like this. They have their workstations, then they have whatever is between them and their infrastructure. If it's the internet or whatever, that's the cloud. So then they've got the drone server, and in this case, it's GitHub that they're using. Maybe they're running this in Kubernetes or AWS Elastic Container Service or AWS Elastic Beanstalk or Google Cloud or DigitalOcean. Doesn't matter. You can run drone on just about any cloud service or self-hosted service, as long as it supports running Docker containers. And you can connect it to many source code solutions, not just GitHub. I'll focus on GitHub in these examples, but it supports Bitbucket, Gitee, and a couple others. So in these examples, the team has decided to run drone connected to their GitHub cloud. It also supports GitHub Enterprise hosted, but and the team has decided to run their containers as EC2 on their EC2 instances directly in this imagined scenario that I have for you. So launching the drone service is just as simple as running the Docker image with the necessary variables passed. The link below in these examples will go directly to the official documentation if you want to read more. So yeah, this is the basic way of how you'd start the actual drone server process. So that's fine. They can start the process, but the team would quickly realize that the default drone database is SQLite, which is not a good idea for a production level service. So drone recommends Postgres. It also supports MySQL. We use MySQL, and we've never had any issues with it, but their official recommended database is Postgres. Most cloud providers these days will offer one of those databases as a managed service. So, the extra overhead of managing a database should be pretty minimal these days. So back to how we're starting the drone container process, we have to add a couple new variables. The drone database driver and drone database data source variables. So all the user information, logs, Git repository information, everything gets stored in that database. The drone server doesn't keep any state locally. So the upgrade process, when you're having to plan your upgrade cycle, becomes much simpler than on some other solutions that maintain their state locally. All that state is kept in the database, which is a nice feature of drone. So back to our team again. Now the team's ready to run some pipelines. So they need to bring up a runner to execute those pipelines. Drone supports multiple runners. We will focus on the most common runner, which is the Docker runner. So here we had the server and the database we talked about before. So now we'll add the Docker runner. So the Docker runner is off on its own instance in this example, and it communicates directly with the drone server process, and the drone server process sends it pipelines from the build queue to execute. Here's the command that we use on that instance to start the Docker runner process. I want to point out here that drone runner capacity is set to 1 intentionally. That's what we do, and it means that only one pipeline will execute at a time on that runner. And we feel that it gives our engineers more predictability than potentially running more than one pipeline at a time on any agent. If it's just one at a time, team knows that anything that's running, is only happening from their process. There aren't other processes happening on the machine that could be taking up resources. So, but you can absolutely change that value if it makes sense for you. So let's fast forward a few weeks for this team. They're getting pretty excited at this point. They're starting to run real pipeline workloads. Adoption's growing, but they notice now that pipelines sometimes sit in the build queue as they wait for the Docker runner that one Docker runner to become available. So that's not great. So before, again, we had the server, the database, we had a runner. Here we now have plural runners. So here we've added 3, but imagine that could be as many as the team needed. It could have been dozens, could even be hundreds of agents, depending on their organization. So that's great. Now we've got all these agents. They can do a lot of work. However, this guy, he's from finance, and he really wants to know why their AWS bill just increased by however much. He'll probably say, why are we running all those instances all the time? Do we really need them running 24/7? And he's right. The service doesn't need all those runners all the time. They only need to be there when there's the demand for them. So back to our diagram, we got the server, database, Docker runners, and luckily, Drone provides something for autoscaling. So in this diagram now, there is an autoscaler that is its own process off on its own instance. And it has its own database too, to keep its state. And the autoscaler keeps an eye on Drone's pending job queue and launches or terminates Docker runners as needed. So this has been great for us. To give you an idea, this is the Meltwater Docker runner count over time. And you can see that most of the time we're at 4 runners, which is our minimum. And then we'll scale up, to 15 to 20 agents pretty regularly. But then once in a while, we get a huge spike, can be up over 70 runners. And this is because Drone supports triggering pipelines with cron jobs. So we have a team that schedules weekly tests of dozens of repositories all at once. And that's not a problem at all. The autoscaler sees all those jobs in queue and launches runner instances. And then when things quiet down, it destroys them. So for us, this is really the killer feature of Drone is this built-in, easy to use, very effective, super stable autoscaling. So this is how you'd launch the autoscaler Docker process on that other instance. So you'll see variables with agent in the name. The autoscaler calls agents Docker runners interchangeably. So the autoscaler also is compatible with more than just AWS. It works with Google Cloud, DigitalOcean, Packet, and a couple others. But this is specific to AWS. The autoscaler supports just about any parameter that you might want to customize on your runners through passing environment variables. For example, like instance type, root volume size, and that kind of thing. And I want to show how the autoscaler process is actually launching and communicating with the agents, with the runners. I think that's important to understand. So if you've worked with launching machines in the cloud, hopefully you're familiar with Cloud Init, which is a method of configuring an instance at launch time. So here's the actual Cloud Init configuration passed to AWS when the autoscaler launches Docker runners. So at the bottom, there's the link, the actual source code where this came from. And you'll notice this config sets the Docker process config. The autoscaler actually communicates with the Docker process securely running on the agent. And that's how it launches the Docker runner Docker container. And yeah, I think that's important to understand when you start looking into the autoscaler. So you can stick with the default Cloud Init that we just looked at. And if that works fine for you, that's great. Or you can pass your own Cloud Init. So Drone has a nice big warning on their documentation saying that this is an advanced feature and should be avoided unless absolutely necessary. So keep that in mind. But in our experience, it's been extremely valuable to be able to pass our own Cloud Init config to do things like add our own monitoring processes, other customizations. Like we actually changed the whole underlying OS and pass our own AMI. So we use Amazon Linux, and I believe it will use Ubuntu or Debian by default. So it's really flexible. So back to our startup story. Here's two developers hanging out in a coffee shop. They are off in a different office. They're not part of the team that's running Drone, but they're hanging out and just chatting about their experience with Drone. And one developer mentions that he likes it, but he wishes that he didn't have to have so many commands to install dependencies, run scripts. This is unscripted, right? We don't want to run scripts all the time. We want to abstract that away. So he has to duplicate he doesn't like that he has to duplicate his pipeline configuration in many of his different repositories. And the other developer says, hey, did you know that you could write your own drone pipeline plugin? So this guy, this is the kind of thing he's doing in all these different repositories over and over. So a pipeline plugin is a custom Docker image designed to be run as a step in a drone pipeline. So this is a link to the official documentation on pipeline plugins, and Drone provides examples for how you'd write your own plugin if you want to. There's also an official plugin registry at plugins.drone.io where you might find a plugin that already does what you need. You don't have to write one. And here's an example of how to use the official Docker plugin from Drone in a Drone pipeline. This would handle the Docker build commands, the Docker build, Docker tag, Docker push, all those commands, you have to duplicate through many different pipelines, all gets, abstracted away into the plugin, and this is all you have to put in. So it's, plugins can reduce a lot of complexity and duplication that way. And of course, this is in the Drone YAML file that's in the team's GitHub repository. So that developer has 100% control over what's put in there. So we had something similar happen in Meltwater. So we had a team in Europe that forked a caching plugin that was available at the time, and they needed certain features that weren't available at the time, and without any support from our team or any interaction with us, they did this all on their own. And they filled that need for themselves. So this plugin is still out there. It's being actively developed. It's got a good amount of traction, and I'm pretty sure it's the most used drone pipeline plugin for caching at this point, which is pretty cool. So back to the architecture diagram that we've got going. I just want to emphasize that for what we just talked about, nothing had to change in the architecture. We didn't have to, launch other types of agents or install plugins on the server, potentially, taking days, weeks, maybe months to deliver what that one developer needed. It was totally in their hands and didn't require any help from us or from the team running Drone. So back to our startup. Business is good. And, the fast build and test pipelines that they've been able to run, development teams have been able to deliver new features faster. The company's bringing in more clients, and they've grown so much that they're going to merge with another startup. So that's pretty exciting. However, shortly after, they see that the company that they merged with is spending a lot of money on data center costs. It turns out that the company has a custom-built CI solution that not only is it expensive for their hosting, but it's also really hard to maintain, and it isn't very reliable. So someone in management has a brilliant idea of moving everything to Drone. That should be easy, right? Well, back on the team that runs Drone, they probably feel like this. It turns out, after looking into it, it would be a massive amount of work to manually rewrite all of those pipelines from the other CI syntax into Drone syntax. How are they going to get all the Drone to understand that other pipeline syntax? That's got to be impossible, right? Maybe not. So Drone supports something called a conversion extension. So conversion extensions take the pipeline file that drone gets from the repository and does any manipulation that you need and passes it back to drone in drone YAML syntax. So as long as the team can write a conversion extension that does the transformation, they should be in luck. So this is an example of how you would run a conversion extension. So once they had it written, they could start it like this, off on that other agent that was in the diagram. And of course, their extension might take different variables, but Drone provides an example template at the link below to make it easier to write conversion extensions if you're interested. And then back on the Drone server, there are 2 additional environment variables that you have to pass to tell the Drone server to use the conversion plugin, Drone Convert plugin endpoint, Drone Convert plugin secret, and yeah, and then the conversion extension is in the picture, and it's handling any kind of manipulation, conversion that the team needs to do. So here at Meltwater, we had a problem that required a conversion extension as well. We needed the ability to include or exclude pipeline steps or even entire pipelines based on the files and directories that changed in the commit range. So we wrote our own open source conversion plugin called Paths Changed, and it's been extremely helpful for our users. It's open source. It's got a good amount of following and contributions. So it's worked out really well for us. So back to our startup story. Things are looking great. They've overcome some pretty big challenges to meet the needs of their engineers to help them deliver business value quickly. This is how they feel, right? Smooth sailing. Until one day, pipelines start failing. They start failing with this error message. So what could be happening? We're being rate limited. They were being rate limited by Docker Hub and getting this error in all their pipelines. The team's on-call engineer panics. What's going on? So back in November, Docker Hub started rate limiting pulls of public Docker images. So for most developers running Docker on their computers, it really didn't affect them. But for a service like Drone, where pipelines are likely using Docker images from Docker Hub in their pipeline steps, you'll likely hit this rate limit pretty fast. So without authentication to Docker Hub, pulls are rate limited by IP. Likely your infrastructure will share a small number of IPs for traffic out to the internet. And so that limits you to 100 pulls per 6 hours per IP. So luckily, Docker Hub plans, they're pretty inexpensive. You can easily get an account that won't be rate limited and has effectively unlimited pull access. But what does the team do to actually get all of the Docker Runner instances that we've been showing in our diagrams, authenticating to Docker Hub to pull their images? So remember the custom cloud init that I shared earlier in an earlier slide? The autoscaler uses that when it launches agents. And so here we can set the root.docker config JSON file. That's where the authentication is happening to potentially any private GitHub or any private Docker registry. In this case, it's Docker Hub. So here you can set the auth token, and when the autoscaler launches agents, they will all come up with this file written and the token in the right place, and all of the pulls will then start happening with authentication. So back in the autoscaler configuration for how it gets launched, it does require 2 extra parameters to tell the Docker Runner process to mount the config file into the running Docker process, because again, the agent, the drone runner process is its own Docker container and takes these parameters. So That's how you get it to actually take that config file and make it available to that process when it comes up. So there is a great post on describing this exact issue and the solution up at the official drone discourse. And that's a great resource, by the way, for finding how for asking questions and finding out how other people have solved problems with their drone infrastructure. So at this point, the team's drone architecture looks like this. So if you've been doing work in this space for a while, I've been doing this for about 15 years now. Hopefully this looks a lot less intimidating than a lot of other solutions out there. I know it does to me. This is very similar to our drone architecture at Meltwater, and it served us very well for the past 3 years. And with that brings us to the end of the story, but of course not the end of the journey. And I will say thank you for coming. If you're interested in learning more about what we're doing at Meltwater Engineering, we have an official engineering blog at underthehood.meltwater.com. And we're excited that we're doing a lot of hiring right now. If you're interested, we have open positions in offices all over the globe. And yeah, thank you again.